Let's talk about parallelograms. What are they, and what kind of special properties do they possess? Well, by definition, a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. That's why we call it a parallelogram, is because it has two pairs of opposite sides that are parallel. So AD is parallel to BC, and AB is parallel to DC. But there's a lot more going on with parallelograms than just the fact that they have parallel sides. For example, they also have opposite sides that are congruent to each other. So in addition to the opposite sides being parallel, they're also the same length. So AD is congruent to BC, and AB is congruent to DC. In addition to the opposite sides being congruent, the opposite angles are congruent as well. Angle A is congruent to angle C, and angle B is congruent to angle D. And we also know that each of the pairs of consecutive angles are supplementary to each other. And that's actually really just based on the consecutive interior angles theorem that we learned in first semester. Since these two lines are parallel to each other, AB and DC, well, angle A and angle D would be consecutive interior angles from that transversal AD. So angle A and angle D have to be supplementary. And you could say the same thing for angle B and angle C, and angle A and angle B, and angle D and angle C. Basically, each pair of consecutive angles are going to be supplementary to each other. We would also know that the diagonals of a parallelogram bisect each other. That would mean that AC cuts DB in half, so DE is congruent to BE, and that DB cut AC in half, so AE is congruent to CE. A common misconception is that this theorem tells us that the diagonals themselves are congruent, and we don't know that. In fact, if you just kind of eyeball it, DB appears to be longer than AC is, so these diagonals themselves are not congruent. What this theorem tells us is that the diagonals cut each other in half. They bisect each other. And then one last thing that's kind of cool about parallelograms is that all that you need in order to prove that a four-sided figure is a parallelogram is proving that one pair of opposite sides is both parallel and congruent. You could also use any of the other things that we just learned, that their opposite angles are congruent, or that their opposite sides are congruent, that their consecutive angles are supplementary. All of those would also be sufficient to say that it's a parallelogram. But this is a pretty nice little shortcut because you only need to know two of the sides. If you can show that two sides are parallel and congruent, then it must be a parallelogram. Well, that was a lot of information, so let's recap really quick. If you have a quadrilateral that is a parallelogram, then its opposite sides are parallel, and its opposite sides are congruent. You would also know that its opposite angles are congruent, and its consecutive angles are supplementary, and you know that the diagonals cut each other in half. And we also learned that if one pair of opposite sides of a quadrilateral are both parallel and congruent, then that quadrilateral must be a parallelogram. So let's use all of that new knowledge to answer each of these questions. Which side is PQ parallel to? Well, here's PQ. It must be parallel to the opposite side, which would be side RS. And your reason is the definition of parallelogram. Hey, by the way, that's how we can abbreviate parallelogram because it's like a really long word, and who wants to write parallelogram every single time? So instead of parallel, just write the little slashy symbols that we have, which already meant parallel in our minds. So it's a parallelogram. Fun little abbreviation. PQ, which side is it congruent to? Well, it's congruent to its opposite side, so again, my answer would be RS, but my justification this time would be the opposite sides of a parallelogram theorem. The definition of parallelogram tells us opposite sides are parallel, and the opposite sides of a parallelogram theorem tells us the opposite sides are congruent. And what about PT? That's this little segment right here. It must be congruent to TR because of the diagonals of a parallelogram theorem. We know that this diagonal QS cut this diagonal PR in half, so PT must be congruent to TR. Let's talk about the angles. Angle PQR, so we could call it angle Q if there wasn't these annoying little diagonals in the middle. This angle right here is congruent to this angle down here, angle S, which we have to call angle PSR. And that reason would be the opposite angles of a parallelogram theorem. What about supplementary? Which angle is PQR supplementary to? Well, there's actually two answers, right? Because each of the consecutive angles are supplementary to each other. So angle PQR is supplementary to angle QPS, so these two angles are supplementary. And also angle PQR is supplementary to QRS, so these two angles are supplementary. And your reason is the consecutive angles of a parallelogram theorem. What about angle PTQ? It's kind of covered up by my answers here, but that's this little angle right here. It has to be congruent to, RTS. That's an old school reason, vertical angles congruence theorem, since those are two angles created by the intersection of two lines and they're non-adjacent, they have to be congruent by the vertical angles congruence theorem. All right, let's get some numbers in here. Given that this four-sided figure is a parallelogram, what is the measure of angle L? Well, it would have to be 76 degrees because it's the opposite angle from angle J, and angle J is labeled as 76. So by the opposite angles of a parallelogram theorem, angle L must be 76 degrees as well. Okay, well what about angle K? Is it 76 degrees? Nope, it's 104 because of the consecutive angles of a parallelogram theorem. These two angles are consecutive angles, so that means that they have to be supplementary, or they add up to 180 degrees. So what do I add to 76 to get to 180? That would be 104. So what's angle M? Also 104. And there's a couple different reasons that you could give. You could give the consecutive angles of a parallelogram theorem again, if you're thinking that 76 plus M is 180. Or you could use the opposite angles of a parallelogram theorem if you're saying, well, angle K was 104, so angle M must be 104 as well. Let's talk about some segment lengths. How long is KL? It must be 8 feet by the opposite sides of a parallelogram theorem. Since side JM was 8 feet, side KL is across from it, it's opposite from that side, so they must be equal. What about ML? Well, it would have to be 9 feet for the same reason. Since JK was 9 feet and ML is opposite from JK, they have to be the same measure. And what about NL? Well, it would have to be 7 feet because that's the length of the other part of that diagonal. Since the diagonals of a parallelogram bisect each other, I know that KM cut JL in half. So since half of JL is 7, the other half, NL, must also be 7. Now let's see if we can calculate the value of each of these variables. Let's just go in alphabetical order. Could you figure out what W is? Well, yeah, it's kind of like what we were just talking about. The diagonals of a parallelogram bisect each other, so W has to be 11 because TQ is 11. So then what's X? X would have to be 8 for the same reason. So again, I just want to re-emphasize the fact that the diagonals of a parallelogram are not equal to each other. They bisect each other. So this diagonal, PR, would be a total of 16, right? Because 8 and 8 is 16. And this diagonal, SQ, would be 22, because 11 and 11 is 22. So the entire diagonals are not congruent to each other. 16 is not the same as 22. What we know about the diagonals of parallelograms is that they cut each other in half. So 8 and 8, and 11 and 11. What about Y? Y would have to be 17, because the opposite side is 17. And what's Z? Z would have to be 10, because of the opposite sides of a parallelogram theorem again. Oh goodness, there is a lot going on in this next diagram. So given that EFGH is a parallelogram, figure out the values of X, Y, and Z. Well, I actually see 3 different X's, so what am I supposed to do with them? Well, one of them is a red herring, is a decoy. This 6x is actually not going to get used when we're calculating the value of x, because we don't know anything about the consecutive sides of a parallelogram. We only know things about the consecutive angles. So don't get confused and think that consecutive sides are going to add up to 180. That's not true. The only thing we know about sides is that the opposite sides are congruent to each other. So to solve for x, I'm going to ignore this 6x and instead just set these two expressions equal to each other and solve. So I find out that x equals 7 inches, because of the opposite sides of a parallelogram theorem. Well, now that we know x is 7, we could plug it in to figure out the lengths of each of these 3 side lengths. And actually we're going to have to do that in order to calculate z. Z is the opposite side to this 6x, so I would set z equal to 6x. But that's 2 different variables. I can't solve an equation that has 2 variables, So I'll take that 7 and plug it in. So z has to be 42 inches because of the opposite sides of a parallelogram theorem. All right, what about y? What am I going to do with these two? Well, those are opposite angles in a parallelogram, and I know that opposite angles are equal. So I can set those two things equal and solve and find out that y is 12 degrees because of the opposite angles of a parallelogram theorem. Okay, well, given that ABCD is another parallelogram, how are we going to figure out x and y? Well, you might be tempted to say, okay, well, A and C are opposite angles in a parallelogram, therefore they're equal to each other, so 17x equals 5y plus 3. But that equation would have two different variables, and I can't solve an equation that has two different variables. So instead, you need to focus your attention on the two expressions that have x's. These two, angle A and angle B, are consecutive angles, and I know that consecutive angles are supplementary. So I can set those two variable expressions equal to 180 degrees and solve. So x must be 4 degrees because of the consecutive angles of a parallelogram theorem. Now I can do what we were talking about earlier of setting 17x equal to 5y plus 3, but instead of 17x, I can say it's 17 times 4. So solve that equation, and we find out that y equals 13 degrees because of the opposite angles of a parallelogram theorem. And that's all you need to know about parallelograms. In our next few lessons, we're going to focus on special types of parallelograms, including rhombuses, rectangles, and squares.